In today's video, we want to talk about histograms. But before we start on histograms, I want to go back and look at the displaying distributions that we looked at previously in the group activity. And in that activity where we were looking at different types of graphs, different shapes of graphs, distributions, bar charts and dot plots and things, and what we were looking at in all of these different types of graphs is we were really looking at where are the outliers of the data? Where's the center of the data? What's the shape of the data? What's the spread of the data? So we have all these different ways of describing the data with different kinds of charts and graphs. And today what we want to look at is one specific type of graph, which is known as a histogram. Now, before we get into the histograms, I want to go back and look at the answers from yesterday on the display distribution activity. So right here where we had the matching of the dot plots, and we had these 8 variables, and then we had them matched with these 8 graphs, and I know like 6 and 7 were the same, so you have a little bit of differences you could have in these, but I want to kind of show the answers. So if we go back to here, these are the answers for graph 1 through 8 that match up with those. So graph 1 is F. So if we go back here, graph 1 is the top one here, and then the variable that matches with is F, the age at which a sample of mothers had their first child. So you can go through and check those and see how you did with these answers here down the side. Now, as we move forward, let's talk about a histogram. A histogram's a little bit different from just your normal bar chart because in a histogram, your bars, the height of the bar represents the frequency. So that means the height of the bar represents how many of them there are. And the width of the bar represents some range of numbers. Here, this represents 20 to 30. So there are 3 numbers that are between 20 and 30. You don't know what they are individually, but they're between 20 and 30. Now there's some shapes. These are the same shapes we talked about in the previous displaying distributions. We can have symmetrical histograms, and symmetrical just means, you can divide it right down the middle. It's the same on both sides. It could kind of be this mound shaped, or we could have something that is symmetrical like this, or we can still divide it right down the middle and both sides are the same. Another shape we can have is uniform. Uniform means it is perfectly level. Every single bar is exactly the same height. We also have non-symmetrical shapes. And the ones we really want to talk about here today are what are known as skewed graphs. And the important thing with skewed is you want to think that the data or the graphs either rise or fall for skewed graphs. And the key to whether it's skewed left or right is which way does it go. If it falls this way or the tail is to the left, it's skewed left. If it falls this way and the tail is to the right, it's skewed right. And I mean the tail because sometimes we'll have data that will look something like this. And then you get the smaller and smaller numbers like this. And that tail, if you think of it as the tail, is going to the right. So what we want to do today is we want to talk about how to construct a histogram. And we're going to have some rules to follow to construct a histogram. Now, I should say, when we're constructing a histogram, it's a little bit different whether it's discrete or continuous. We really are looking at more kind of continuous data, a whole bunch of values. But it works the same either way. Sometimes it's just harder with continuous with you make our classes, as you'll see. So here are our steps. So we should have between 5 and 15 classes. You will always be told how many classes you have. That's not something you have to determine. The class width should be a whole number. The classes must be mutually exclusive and exhaustive. All class widths must be equal, and there should be no holes in the class boundaries. Now, with that said, let's go through an example, and then I'll come back and explain what each of these mean. So let's start off with a set of data. Here is the data. These are the record high temperatures for each of the 50 states. And we want to construct histogram, and to do that, we're going to first construct what's called a frequency distribution table or a grouped frequency distribution table. And we want to use 7 classes. Now, if you follow in your notes, and the bottom of the notes, the first thing we want to find is the range. And you notice the range is the highest value minus the lowest value. And our highest value is 134, and our lowest value is 100. So our range is 134 minus 100, which is 34. So now let's flip our notes to the back and do the next step. We want to find our class width. And it says on the class width, we take the range, 34, divided by the number of classes, which is 7. And that gives us 4.86. And if you're looking at your notes, you will see it says round up to the next whole number. So this number becomes 5. That is our class width. So if you go back to one of our guidelines, it said a class width should be a whole number, no decimals. Now it's a little misleading when it says round up, because there's really no rounding at all. If we had, in this case, 4.8, we go to 5. But if we had 4.1, we also go to 5. If we had 4.01, we'd also go to 5. You just go up to the next whole number, because you always need your class width to be a whole number. So now that we have our class width, we are now ready to start to build our table. So first off, we're going to go talk about the class limits. The way we write the class limits is we start with our lowest number, 100, and we add our class width to start the next class. Our class width was 105, so this becomes, or 5, so this becomes 105. We add 5 again, 110. Add 5 again, 115. Add 5 again, 120. Add 5 again, 125. Add 5 again, 130. Now, this is where a couple of our other rules come up to play. The first says our classes have to be mutually exclusive. What that means is I cannot have something like this. I can't have this be 108 and this be 109 or something, because now where does 107 go? 107 fits in both of them. I can't have that. So you can't have any overlap. That's what the mutually exclusive means. They can't overlap each other. Secondly, they have to be exhaustive, which means I couldn't have this only go to 103 and the next one start at 105, because where does 104 go? So that's what we mean by exhaustive, mutually exclusive, no gaps, no holes, that these have to go in order. So if this goes from 100 and the next one starts at 105, this would be 104, 109, 114, 119, 124, 129, and 134. So you'll notice we go from 100 to 134, no gaps, no breaks, no overlap. Now, it will not always work out that your lowest number goes exactly to your upper number. Sometimes this top class may run over based on the pattern, but that's okay. Next, I'm going to come back to the midpoint. I'm going to go to the tally. And to do the tally, all we're going to do is go through our numbers. So first number is 112. So that is in this class. So I put a mark. 100 is here. I put a mark. 127 is here. 120 is here. 134 is here. 118 is here. 105 is here. 110 is here. All I'm doing is counting them. And what I want to do is I want to go through and count all of these numbers. Now, if I do that, having already done this, I get 2 here. 2, 3, 4. I get 8 here. I get 18 here. I have 13 here. I have 7 here. And then I have 1 in those. So when we get to the frequency is just how many, which that's just the tally marks. So that's just going to be 2, 8, 18, 13, 7, 1, and 1. Now, one thing to check and see if you've done this correctly is all of these numbers add up to 50 because there are 50 numbers down here. That's a quick check. Another thing we're going to use as we go to make our chart here in a second is the midpoint. And the midpoint is just, as it says, the middle. So from 100 to 104, you just find the middle. You find the average. 102, 107, 112, 117, 122, 127, and 132. And we will use these numbers in a second as we go to make our chart, our graph, excuse me. So here is our graph of our histogram. And there's a couple ways you can do this. If you have that frequency distribution chart in front of you, we can make this 100 to 104. And that number was 2. And so we can make that bar. And let me go here, 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. And there's 20. The next one was 105 to 109. That was 8. Now, the one way of doing this, instead of doing it like this, 110 to 114 is 18. Instead of writing all of the numbers at the bottom, one way we can do this to make it a little bit easier is just to write the midpoints. So I'd go here and I would just say 102, 107, 112. So instead of writing both class limits, I can just write where the midpoint is. So the next one would be 13 is 107. And then I would have 7 was 122, 1, 127, and 1, 132. So we can do a histogram either way. I have a tendency to like using the midpoints just because it's a little bit easier than writing down all of the numbers. All right, you are now ready to do the homework where you're going to have to get a set of data. You need to complete this frequency distribution table. You're going to be given the number of class limits. You're going to be given, they have to determine what are the class widths. Once you determine the class width, you can then fill out your class limits, do your tally, and then do your frequency.